Welcome into Weld.com, everyone. Today we're going to jump on some stick welding. Got some groove welds, some fillet welds. We're going to do some open root 60-10. We'll do some 70-18. We're going to show you just how easy it is to weld it, of course, in the flat position, but just how similar welding in the overhead position is to welding flat. Let's talk about it. Now, for today's episode, I don't want to get too involved with the theory of things. I do want to talk about these welding positions because I do believe that a flat and an overhead have a lot of similar characteristics as you go about welding them. However, if you want to get more in depth with the electrodes we're using, like 60-10, 70-18s, the theory on stick welding, the American Welding Program is a partner of ours that we've teamed up with to help give you a little bit more out of what we teach here on the YouTube channel. You can go over there and you can see a lot more classes, courses, and even books that you can purchase for your own individual use or maybe for your classroom for your students. I want to go over more of the hands-on stuff, more of these variables like arc length, travel angle, travel speed, and work angle. What we're going to be doing today, which is a 2F and a 4F, and we'll have our 1G and our 4G welds. We're going to weld them out today, paying attention to the biggest variable today, which is gravity. With any flat weld, gravity is going to let your weld sit really flat here on your groove weld, whereas on a groove weld overhead, it's going to want to sag. It's going to want to make your welds a little bit heavier. And the biggest thing that you can do to mitigate that or keep these very similar, especially with the 70-18, is that arc length. We're going to try to maintain a very similar arc length for these fillet welds and for these groove welds when we're welding with the 70-18. We really want to be nice and close with that arc length. Now, I know the rule of thumb is like an 1/8 inch to an 1/8 inch, depending on what rod you're using. I'm going to just say as close as you can get to that material. With flat, you have a little bit more room to breathe. You can kind of stay out of it a little bit to kind of keep that puddle going. But with an overhead weld, I want you to be a little bit too close because that weld is making a lot of action inside that plate overhead and then it's dropping back down, so we need to compensate by pushing up a little bit more. Other variable that's going to stay the same is going to be our travel angle. Whether we're doing a root, fills, cap, 60-10, 70-18, I'm going to be dragging about 10 to 15 degrees. That's going to be with both of these rods, so that's not going to change, fillet or groove. The next thing that's really not going to change is going to be our travel speeds. Now, our travel speed is going to be nice and slow. When it comes to a fillet weld and even the groove welds with the 70-18, 60-10, open root, we got to fill all that stuff in. And I think the biggest thing that a lot of newbies get in trouble with is they just start welding too fast. Weld too slow and then try to speed up. But I think most of the time people are trying to get in and out of there, not do tie-ins, so they're not letting it fill in, and so we're getting undercut, we're getting a lot of other things. The biggest variable that's going to change is going to be our work angle, and this is going to directly be affected by gravity. Our work angle is the angle that our stick rod's going to come in at each one of the beads that we put on. For our fillet weld, we're going to put one bead on the first root pass, and then we'll put a 2-bead cover and then a 3-bead cap. The goal is to get our leg lengths the same. Same thing with our overhead fillet weld. We're going to try to do the same thing. Now, if you noticed, I'd stacked my beads different than the other side, whereas I started on this bottom plate here, I started on this side here because of gravity. I want to stack my welds, so I never want to stack my welds top to bottom. I want to try to stack them bottom to top. Not only that, but the best way to keep these leg lengths the same and not having one significantly longer than the other is just get a better view. I think those are the two biggest things that's going to set us apart to making these welds the same, is getting comfortable. Flat, 2F, super comfortable. Overhead, not so much. So we got to find a way to be comfortable and have a good line of sight, both plates, both sides of our bevel, and we maintain these variables. Only thing that's really changes in our work angle. Depending on what bead we're going to be doing is where we're going to aim. Let's get this machine set up. It's pretty simple, and then we'll go over everything else. Just flip on the back of the machine, it powers right up. You got 2 buttons here and a knob here. Probably my favorite thing about this machine is just how simple it is. We've got stick welding for all of your basic electrodes. That's where we're going to be welding our 70-18s at. We're going to be running 1/8 electrodes, so we're going to be keeping it about 120 amps. For my amperage for both of these welds, I wanted to keep it constant so that I can show you just how similar they really are. If I'll do anything for an overhead weld, I might bump things down 5. But I think 120 is going to be a nice range because usually on a flat weld, I might go a little bit hotter to 125. Then when you have your 60-10 modes, that's where we're going to do our open root welds. We'll be dropping anywhere from 75 to 80 amps on our 60-10. We want to make sure we put it on this mode because this machine welds a lot better open root welds running at 60-10 when we have it on. Of course, it has your lift and high frequency TIG and our pulse settings if you want to get into all that. Today we're going to focus strictly on the stick. I've got my polarity at DC positive. That means my ground is in the negative and my stinger is in the positive. Pretty simple. I will say I think the least favorite part about this machine for me is the fan on it. For a little machine, that sucker is freaking loud. front of us we have our 2F fillet weld and we've got our 1G groove weld. I'm going to end up doing half of this groove with a 60-10 flat and half of that groove overhead. I've got the same fit up. It's a 332 land and gap. I think that's a good rule of thumb, is to follow the same land and gap. I think it's a personal preference unless you're having to be following a particular procedure. I always start with the 332 land and gap no matter what. I would say on 3/8 plate, vertical overhead, downhill, uphill. I like a 332 to get going with. We've got, of course, our 1/8 electrode 60-10s, and we've got our 1/8 70-18, some Lincoln brand stuff. We're going to do a 3-pass fillet weld flat on this side and 3-pass fillet weld overhead. And again, the goal here is to try to get comfortable so that we can get both of these welds to look almost identical, even though we did them completely opposite of each other. I will say sit down. We've got FR material on, but even FR is not going to protect you from a giant spark in your crotch. I got valuables right there, so I like to stay standing. I would say try to avoid sitting if you can, at least with this type of stuff. Your line of sight is super crucial. I just put some new lenses in my 3350 Advanced Series Lincoln welding hood. It looks way better now. You'll be baffled just how bad it can get whenever you've just been welding with the same lens, cover lens, for so long. It just slowly gets worse and worse over time. So just go ahead and open up a new pack of cover lenses, peel that old one out. We got 2 clear lenses in this hood. I took the front one out, re-replaced it, clear as day. It looks way different. Slap that sucker back in, and then I'm going to take a microfiber towel, just clean up the ADF inside and out all around, and then replace that inside cover lens too. You'll slap your hood on and you'll feel like a whole new freaking welder. You'll be looking around just like, oh my goodness, why have I not been done this before? Stack up on your clear lenses, keep them on there. You don't need some super thick gloves to stick weld. As long as you keep your hands away from the fire, you should be square business. We're gonna do 1 pass, 2 pass, 3 passes. So that's 6 welds total. And all I'm going to basically show you is the different work angles that I'm going to need to focus on as I do this 2F weld. Like I said, always be comfortable looking into it. I'm going to be kind of floating around here more or less for the cameras. Now what I feel is comfortable may not be what you think is comfortable. I have to focus on both of these plates trying to get this first weld to hit both of them the same. I'm staring at the majority of this plate. I need to make sure my line of sight is over here so that I can make sure that I'm getting good connection and good fusion into this plate that's evenly distributed. Not only that, the fact that we're in the 2F position might make me favor, instead of being straight in at a 45, I might actually tilt up a little bit more to compensate for the fact that gravity is going to be pulling at that top toe. Let's get into it. We'll light up, get a puddle established, try to get my hand out of the way. A little bit of a drag. As my rod burns, so does my work angle. My hands will drop, the rod starts to get shorter. You just want to make sure you maintain that work angle, so you might have to turn your wrist, trying to favor more of the top plate than the bottom. A nice close arc length, as close as I can get, all while really heavily favoring that top plate. Getting shorter on the rod, now that plate's getting in my way. Roll my hand a lot. I'm trying to maintain that. Getting a lot of arc blow. Oh my goodness. Look at that arc blow. Guys, I don't know if you remember our video about stick welding and arc blow. I can move my ground at this point. What I'll probably end up doing is just welding the other direction. That arc was crazy, it was sporadic. We got these heavy boogers and BBs on the end of the plate. What we did need to learn is that we needed to favor that top plate a little bit more. You can see we got a nice clean weld. The biggest thing that we're going to look for is undercut across the top toe there. We did a really good job of that, favoring this top plate a little bit more than this bottom so the leg lengths maintain even. I would say at the start of this weld I'm actually favoring this plate more, and then we kicked it up a notch and we got that weld right where we needed to, up until we had no control from this arc blow. If you do end up getting some arc blow, get a chisel, get a grinder, get some of that off. I'm going to mitigate this next round by moving my ground closer, maybe even to the other side, and I'm also going to weld this way instead of that way. But the biggest thing that we need to take away now that we've got this bead where we want it is when we go to put this second weld on there, we want to be aiming for this bottom toe, but we don't want to get carried away with that work angle pointing too much at this bottom plate. Again, with this being the position that it's in, I want to cover 3/4 of this weld. I want to cover past halfway with the toe of the weld that I'm trying to do now and barely come out a little bit. So we're going to be snug up on that thing if we can have anything to say with it. We switch sides of the plate. We're going to weld the other direction, hopefully to prevent some arc blow. Aiming at the bottom toe, but not favoring the bottom plate. I want to favor more of the weld than the plate. Gravity will let us flow into our bottom plate. I want to just try to cover like 3/4 of that weld. For my line of sight, I could pretty much be looking at the bottom plate more than the top, but I want to make sure I'm covering more of the weld. Looks like we already got rid of that arc blow, so that's good. Definitely got a solid size weld. I think the weld size is definitely what we're looking for there. Biggest thing that you need to take away from looking at this right now is I don't see a whole lot of that weld right here. There isn't a whole lot of that bottom bead showing. I've got just a little bit of an edge on it. That first bead is taking up so much of that. And now whenever I do this top bead, there's not that much to do left. The biggest issue that I see most people doing is they do that first bead looking at it like this, and then they go do the second bead looking at it the exact same way. You've got to change your angle and look at it like that. You've got to look at this plate now, hard and heavy. We're trying to just cover half of that weld we just did though. I'm use the old crescent wrench hack right here to give me something to prop up on. I'm gonna get on a knee because I really want to be looking at this weld dead on. I want to look at that top plate more than I want to look at anything else. Puddle's established. You can start taking off. I want to make sure that I got that puddle on that top plate and let it just dribble down and find that spot where I'm covering half of that weld that's underneath me and pointing still at that top plate. If I deviate too much and start pointing down, I'm going to have more of my leg lengths uneven, favoring the bottom. The idea is that you're super locked in on where that bead placement is. And you just never really want it to get carried away from you. Every time you put a bead down, you should be definitely checking, trying to at least eyeball it. Am I favoring one more than the other? Are my hands falling? Is my bead not staying on line with things? I think that's another thing that a lot of people do, a lot of newbies, as that rod burns, their hands drop, and that's a big deal when we get to this overhead weld. I think we've got a pretty even leg lengths on these right now. There may be just a hair of a valley in the middle, trying to keep up with that. If you can make little adjustments to fix some imperfections as you work your way out and don't get like 6 bead deep and you've got a crazy bad valleys or crazy bad legs, you're out of it. You might as well just grind it all out. So we could probably make some adjustments. We'll do the last 3 beads, where the rod goes and what the bead looks like. Boom, boom, boom. Now, being that this is a 2F weld, gravity is pulling on it. Every bead has a home. The first bead, we want to make sure we're favoring the bottom plate, but we're still tucked up into that weld. If you start favoring this bottom plate and you start moving too far out, that's where that bottom leg really gets carried away. And then we put our middle bead. Still want to cover half of the bead we just did because we want to tie in without any overlap. But we still need to have enough bead there so we don't fall short on the bottom bead and still come out with an awkward leg. I had maybe just a hair of a valley right in between those 2 welds, and I think if I could have scooched up that little bit, just keep it tucked up to this top plate a little bit more, I could have avoided that. However, both of my leg lengths are nice and even. Those beads all have a home. You got to be planning as you go. You can't just be throwing things on. And if you notice those first 2 beads, my eyesight was looking more at the bottom plate. And then when I really needed it, I went and favored that top plate so much more, because that's what's necessary. Nothing is going to change from any of this, guys. The arc length, the travel speed, all this is going to be remaining the same. We're just going to flip things upside down. Whereas most people favor this bottom plate for a 2F weld, now they're going to probably favor the plate that's in front of them a little bit more than the plate that's above them on a 4F. Let's talk about that. Getting comfortable is going to be the big thing. Overhead does not mean it needs to be over your head. You don't need to be reaching for stuff. That's going to be one of the hardest things about overhead, is your arms are going to get tired. If you can choose to get closer to it, I'd rather have my coupon to be eye level, at the right height to be able to look at it. I'm going to not stand underneath it for obvious reasons. It's overhead, it's going to drip, but the more you see dripping is that arc length that I was talking about. Now, it might look like you're really close, but the fact that this rod is digging, it's giving you actually a little bit more room in there to kind of keep a closer arc length. Sometimes I might even feel the fact that I'm rubbing that material because of how close that I am. Most people are looking at it like this, so they're not paying attention to this top plate as much. They're paying a lot of attention, focusing that bead right there on that plate, and then they start with that leg length going too much on this plate, whereas on the flat we might have had it on more on this bottom plate. I want to be able to hit both plates evenly. I know gravity is going to want to fight me on this top plate, and it's going to run down to this bottom plate, so I need to be more looking at it like this. Still not underneath it technically. I might could do something else with my hands to try to avoid it and understand where my hands are going to end as far as towards the end of the plate. maintaining the right travel angles, work angles, all that good stuff. The biggest thing that I need to keep in mind is I can't just look at it like this. I need to look at it like this and keep a tight arc length in order to make it look nice, flat, and smooth. Right now I'm favoring that top plate. I would say 2/3 of that top plate to the 1/3 of the bottom plate that I'm staying on. Again, trying to compensate with gravity. As my rod burns, it kind of forces your work angle to change. Just know that and try to rotate your wrists. Try to move your hands, do something to maintain favoring the plate that you want to favor. With a close arc length, slow travel speed. As that rod burns, why are we getting more arc flow? Gee whiz. I'm just gonna cover that up. Golly, that was a lot of arc flow. Always happens in the first joint of a fillet weld for me. We'll give this a jimmy. Looks good. Big common discontinuities that you'll get is undercut on this top plate, and again, that usually has to do with welding too fast or not pointing up enough at that top plate. It looks like we got a good weld. That arc flow gave us some hell back here, and it put a little bit of porosity in the back side of my weld. On this next bead, we're gonna build from bottom to top. I've seen a lot of newbies, they'll start on this top plate because, I don't know, to them, that's where that T-joint intersects, and that's where they started their 2F, so they wanna start that bead there, and then they put that next bead below. That's gonna give you undercut. That's gonna give you some weird overlap and roll in your welds. You wanna stack your beads, so we're gonna go bottom to top. You can look at this next bead pretty much dead on. You don't have to even worry about this plate because you don't need to tie into it yet. It's not until you get to this next bead where you gotta be looking at it pretty much overhead. Let's run those two. Well, I forgot to weld the other direction. Probably gonna get some arc flow at the end of this guy. I don't need to look up as much. I do prefer to weld towards myself or then away from myself. This is where your bead starts to drop towards the end when that rod's burning down. Your arms are getting tired and your weld wants to run away, wants to go down. You gotta know that that's gonna happen. You're gonna feel that, so you gotta just tough it out. Really, that's all you gotta do is just deal with it, and then you can make it to the end of the plate. As you weld, that rod's burning, and it makes you wanna kinda drop your hands like this. We wanna not do that. We wanna make sure we're maintaining it, especially when we get to this top plate. Let's go ahead and wire wheel this. I'm definitely doing what I was looking for, which was favoring this plate right here, but still covering up the majority of the weld that we did before. Knowing I want to favor this top plate more, and I want to get rid of that arc blow, I'm going to weld the other way, but I'm also going to be really looking up, or really be favoring this top. Like you can see my difference in body positioning is channeling that overhead position now. I have more of a push angle than I'd like. So I'm really hitting that top plate. I can almost feel my rod rubbing the material, trying to maintain that close arc length. If you can kind of feel the metal the whole time, and you're at least maintaining that arc length you're trying to maintain. You shouldn't see any craziness at the end of this plate. Again, with the most common defects probably being undercut and improper leg size, like whether or not you're favoring this one or this one more. It looks like we don't have any undercuts, so that's good. I have the porosity at the start. Again, if you don't grind that stuff out, like don't let anyone tell you otherwise. You can't just weld over that stuff. It's still there. It can still bubble to the surface. It's just a problem for future you to deal with. Anyway, I think I might be starting to favor this plate a little bit more than this plate, so I'm really gonna make an effort on this next weld on the bottom to tuck it up higher. And I'm already trying to come in where I'm barely gonna tie into this bottom plate on this first weld. I'm trying to favor more of the welds. I wanna just see the bottom edge of my bead here hit that bottom plate. So we're still gonna have a little bit of an angle facing up, more than facing that bottom plate. I want to go higher up on the weld. I want to just see the edge of that bead I'm welding right now really land next to the edge of that first bottom bead. Looks good, the slag's peeling. If you're getting peelers, you know you're getting the right travel speed and the right arc length. If you start seeing like humps and bumps and waves in your weld, it's probably because you're not maintaining that arc length as well. Your hands are dropping, you're going back in. Hands are dropping, you're going back in. So if you got a wavy weld, your hands ain't staying up. So we're really going to start going from this angle here to this angle here, not quite needing to hit the top plate, but I want to get really freaking close. I want that top toe of this weld to nudge the edge of that plate. I know gravity is going to take that bottom toe and drag it a little bit more than I think, and it should tie into that bottom bead just fine. For this last weld, we're going to really be aiming up. Get a wider stance, whatever you got to do, so that you can lean over and look almost straight freaking up. I want to pretty much be only favoring that top plate, letting the edge of that weld edge that other weld. But this is the overhead weld of this joint right here. My hand wants to drop. Gotta know that. Maintaining all these angles and travel speeds. Just because it's uncomfortable doesn't mean you need to hurry. Stay in it. Finish the weld, finish the rod. If you do feel uncomfortable and you're losing one of those variables, stop welding. The goal here was to try to get a nice flat smooth weld. It looks like my highest bead is probably the nicest one, and it got us back on track to being even on the legs. I will say it's a little bit more convex than I'd like, trying to keep up with that rod angle, trying to keep the legs the same size, and it ended up not being necessarily like a flush top. Let me break it off and I'll compare the two. Now, taking a peek at both of these welds, I went ahead and pulled out a fillet weld gauge. Here we have our overhead weld, and I think from this angle it's kind of obvious. This is the last weld we did, which means this is the top plate. So it was sitting like this, right? I got just one little piece of undercut. Outside of that, everything looks decent. Got a little bit of a valley right in here. But the big thing is that our leg sizes are completely different. I've got a 5/8 on this side, and then I've got probably closer to, I don't know, maybe half an inch on that other side there. So that means our legs were uneven. When I was doing the cap there, I thought I needed to stretch up and look up more, but I guess in reality I should have just kept it a little bit lower to keep those leg sizes the same. Whereas on this back side here, we have a little bit more success of holding both size fillet welds. It got a little bit distorted since we welded this side first, but we have 5/8 more or less all the way across. Got a little bit of a lower leg where that bead kind of tucks in a little bit, and a little bit of overlap on that spot. Did a better job of maintaining the leg sizes, but really when it comes to the bead shape, they're still all flat and they're not any different in size. The only problems that we had were maintaining that work angle. I think this is a good practice thing to do, at least 6 beads, to get you to a point where you can see where you're overlapping properly or improperly. Now, the other thing we wanted to cover was open root 60-10. We're keeping it on DC positive. I'm going to move down to the 60-10 option on the Lincoln Sprinter, and then I'm going to turn it down to somewhere about 75 or 80, and we'll set up for this flat root. Now, even though this is a groove and not a fillet, it's important to still follow those same concepts. You want to be comfortable, so I'm going to be really comfortable right here. I want to maintain my angle as a drag, maybe 10 to 15 degrees. I'm going to start my puddle right here on this tack that I made. Once I get a good puddle formed, right at the feathered edge of it, I'm going to punch in. Now, I'm going to pull forward just a little bit, maybe a little bit of a stitch motion. The thing to take away from a flat weld is the reinforcement is going to be given to you. You don't have to really try that hard, so you don't have to push in as much or go as slow and carry that metal compared to, like, say, when we go to this overhead root. We still want to feel the pressure on the end of the rod, but I'm going to be staying on the top side of the land, where when I get to the overhead, I'm going to be pushing in a little harder. Your rod angle has a lot to do with it. The more you can stay perpendicular, if you have too much of a drag angle, your puddle's going to be a little bit harder. And I can tell you from that, we're going to have good reinforcement. It's just going to be given to us. We carried a keyhole. That evidence alone is going to tell me I got something on the back side of that weld. Don't need to feather too much. We got a pretty good hole there. Looking at 75 amps. We're going to try to maintain those thoughts, trying to stay straight in. If I have to, I'll do a little bit of a drag for a little bit more heat. The goal here is that I really got to be pushing through. I really got to be pushing through. So when we get to that edge, we want to be reaching to that back side. I need a keyhole because I need to be able to get back there. And I'm going to try to push back on my weld, try to stack some reinforcement, feeling a lot more pressure in the groove. This, I will say, is a little bit different when it comes to overhead stick. I'm trying to get that same reinforcement we got. It's going to take more rod because gravity's pulling it down. It looked like we got it at least all fused. Hopefully we got some similar results on the backside. Now looking at this weld, this is the flat portion of it up to this point. This was our tie-in. I would say after I tied in with the overhead, we had some really good reinforcement. And then starting to flatten out, and then I got a little bit higher again towards the end. And I remember at that point, I got a little uncomfortable and I wasn't able to really reach back there and throw that metal back on itself that I thought I could. Here at the start, you can see we've got excessive reinforcement. I needed to turn things down. Turned it down 5, that seemed to be okay right in here, but still stacked up really tight, really heavy. I probably could have even bumped it down another 5, just so you're a little bit more in control of stuff. Probably didn't need to weld that slow, but I couldn't keep my puddle connected because that hole was getting out of control. Right there at the end where I turned my amperage down, we got some good reinforcement on the flat, and then we've got almost a matching reinforcement right here in the overhead, and that's from reaching back further and pushing back on that weld. Now to move on into this groove weld, we got to take our grinding disc and smooth that up. I'm going to go ahead and just throw this in the overhead position. I think you guys understand what it would look like if I did half of it flat. I don't think I need to do that. I think you understand how flat works. Let's weld the whole rest of the plate overhead. Now that we don't have a bottom or a top plate, we have 2 side plates. We want to make sure that this bead hits both of them. I'm going to opt for this angle of 45° up, and I got to be looking pretty much straight up at what I'm doing. I'm going to stand towards the end of my plate so I can work towards being comfortable. Still trying to maintain that drag angle. Arc length is super critical right here. If you don't want to blow a hole, we want to be really close. Again, knowing that that overhead position is going to be kind of digging. Pro tip, don't be stepping on your lead. I think I'm stepping on my lead. I can't pull up anymore because I am stepping on my whip. Don't do that. You won't have to make a restart. If I see any humps or bumps, that means I'm probably not maintaining my arc length well enough, and I'm in and out, in and out, in and out, in and out. That's going to give me a bunch of bumps. I'm looking almost directly up at it, guys, but I'm still standing off to the side a little bit. The trick here again is an arc length that is so close you feel like you're rubbing the steel, favoring both pieces of metal. I'm right-handed, so I tend to want to point to the left. Knowing those things helps you compensate as you go about making this weld. God bless the arc blow today. All we're going to do is just light up on the end of the plate and go back the other direction. It looks like we got it, pretty much everything centered. No humps and bumps if I'm seeing waves. That's the biggest thing with that arc length. If you start seeing a skinny weld and a fat weld, obviously that's your travel speed. Try to get comfortable and make it all the way across is the biggest thing. Now that we've got that in there, I might as well just try to just put a big old weave in it. Just to show you that you're not going to necessarily drip any metal as long as you keep that arc length. So we're going to try to put a big old fat guy right here and see if we can't hang some iron. I'm going to weld this direction to hopefully prevent some arc blow. Alright, now we're going to go bevel to bevel. If you're looking at one side better than the other, you usually get a lopsided bead in there. I think we're doing good. Pausing on the sides, ignoring the center, because it's going to take care of itself. These beads are going to always want to stand tall in the middle if you don't do some fashion of manipulation to get out of the middle. Especially with these 1/8 rods, you can do a little bit more or less with a 332. I'm not comfortable, but I at least want to remember to breathe. This is where that arc blow is giving us heck. Still kind of doing it. Kind of doing a little bit extra oscillation just so it doesn't build up too heavy. That slag got a little bit carried away there at the end, trying to fight some of that arc blow. If you're going to cap something, you got to cap something that's nice, flat, and smooth if you want a nice, smooth, flat cap. And that was just there at the end where we were fighting that arc blow. Everything else is really smooth, really flat. It's ready to cap. I could probably put a 2-bead stringer bead on it. We can call it a day, but you'll know that it's not sagging. It's not heavy in the middle. It's tied into both sides evenly. That's what you're looking for, just as if you would if you're flat. The only difference is you're uncomfortable and you got to put your eyes in the right spot. Now running stringer beads, I don't like just dragging it. You can just drag it, but I think it piles up a little bit more in the middle. So I like to do some sort of circles or oscillation. Forgot this hood had a light on it. That's kind of nice. So instead of just dragging it, I'm going to do some little circles to help spread that puddle out. I want to cover more than 50% of that groove. I know I've said it a lot already, but as that rod burns, man, it's going to completely change things, and you're going to want to be doing some different stuff. Your arc length might be farther away, your angle might change, all because that rod's burning away, and you started off like this and then you end up like this. It's different, so you have to compensate one way or the other. So I was able to tie into this side of the plate pretty clean, a little rough at the start, and then we've got more than 3/4 of that weld, still flat weld, not too high. And the only reason why I'm able to do that is because I'm doing a little bit of oscillation and keeping a really tight arc length. You might could even get away with just a drag. Let's see what just a drag does. My assumption is it might just stand a little taller on the crown, but it might sit good next to this other bead. I don't know. As that rod burns, my angle is kind of a drag angle, pretty good. And then I stepped on my freaking lead again, man. Whew, nothing to make you more crossed at yourself than doing some dumb stuff like that. Get all that slag out of that crater. I'll tie back into this. Got that light shining right where I need it to be. I'm gonna light up just ahead of our crater, come back, trace it. Don't need to really pause on it. That little bit of direction change is all you need. Try to get through that trash as best you can. Stay in the bevels. Overall, pretty good. We got a good tie-in on there. The beads are fairly flat. If you notice these high spots, like right here, right there, you can kind of see that wave in the weld. Especially at the start, just getting that puddle started is kind of tough if you don't have a run-on tab. And at this point, might be a point where I'm starting to drop my hands because that bead gets a little higher. And then I catch up to myself. Still see that again here, a little bit on the tie-in. We started far enough ahead of ourselves where we didn't catch it, but if you start seeing those waves, it's because your arc length is in and out. So make sure you're covering that. You're sitting at the right point of the plate where you can see both bevel edges, or you're sitting on the right part of the plate where you can see both pieces of material if you're doing a fillet weld. It's a harder weld to make than flat. That's obvious, right? That wouldn't qualify you to weld the other positions if it wasn't harder. But you just don't overthink it, because welding's just welding. Sometimes it's just over your head. A lot of what welding is just maintaining those variables. Travel speeds, travel angle, work angle, arc length, travel speeds, did I say that? You guys get it. No matter what process you're doing, no matter what position that you get put in, you have to maintain those variables in order to maintain the same shape weld. Things that did work out great today, of course, was the Lincoln Sprinter. Check out the links down below for the Lincoln Sprinter 180 SI. It's one of my favorite little machines that could. And if you're looking to further your education in the welding industry, go check out the American Welding program. I believe we got a discount code. Everything's down in the description below. We'll see you guys on the next weld. Looks good. Oh, I just took a freaking wire wheel wire to the freaking nose. Ow. Can you see it? Oh, love it.